In order to go a little bit further with our order of operations stuff, we have to take care of a couple things. One being exponents, two being square root. Exponents is the one we're going to talk about today. This is actually a pretty easy concept, but a lot of people don't understand it when they see this form here. So I want to make sure that you understand what this means and have some notes down that you can always refer to. So make sure that you get all of these notes completed. An exponent, this is what you're going to see, something like this. Okay, and there's two parts to this. The big number here is called the base, while the smaller number is called the exponent. If you see this in this form, this is what I would call, and I probably won't spell it right, but let's go exponential form. This would be exponential form, meaning it has an exponent. Okay, we're going to talk about what this means in a minute, but if you see this, this is exponential form. This is the actual exponent, while this is what we call the base. We'll have three different forms that you will see exponents in. The first one is exponential form. The second one is going to be expanded form, and this kind of explains what this is talking about. Basically what we have for expanded form, we have our base number and we're multiplying it by itself however many times the exponent says. So for instance, our base number here is 2. So we're multiplying 2 together 3 different times. So that's 2, and the dot means times. We'll start using that a little bit too. 2 times 2 times 2. This is the expanded version of this. Now the standard form is just the answer. That's it. When you do this, what do you get? And there's a lot of ways you can do this. I mean, you can just multiply straight down the line since it's all multiplication. Sometimes what I like to do is I like to go like this and get the first part, knowing that that would be 4. And then I like to cross those out, knowing I've already used them, and then I bring this down. It's kind of like the order of operations stuff. 4 times 2 is 8. Okay. So my answer to the question, this is the exponential form. That would have been the expanded form, 2 times 2 times 2. And my standard form is just the answer, which would have been 8. All right, we have 3, and here's how we say this. This is 3 to the 5th power. 3 to the 5th power. Some people say 3 to the power of 5. Either way, that's going to be fine. But usually most people say this would be 3 to the 5th power. Okay. What I want you to do is, I want you to try to write this in expanded form and standard form. So if you would like to pause the video now and try it, do it. If not, I'll go ahead and give the explanation. You can copy it down. Expanded form for this is going to be the base number, and we're multiplying it by itself 5 times. So this should be 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5. I've got 5 3s. Standard form is just the answer. So I just need to multiply this together. So standard form here, I could start by multiplying. I'm just going to do, I don't know, I think it's easiest to do this. That's 9. I can cross that out. I'll bring everything else down. And again, this seems like it's extra work, but I really think it's worth it for some people to keep things straight. I really recommend it. 9 times 3 is 27. Times 3 times 3. 27 times 3 has got to be, 20 times 3 is 60, 7 times 3 is 21, so that'd be 81. And then bring down that last 3. 81 times 3 would be 243. 243. You don't have to do that in your head like I just did. I mean, you can, but I'm just showing that that's what it would be when you multiplied it all out. So 243 would be your answer for standard form. Same deal for this one. Give me expanded and standard for 1 to the 7th power. 1 to the 7th power. All right, for this one, expand it out. It's just going to be 1 times itself 7 different times. So 1 times 1 times 1 times 1, that's 4 of them. 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now, this one, a lot of people always want to put 7 for this answer, and it's not. The answer to this would be 1. If you keep multiplying 1 times 1 times, it's always going to be 1. 1 times 1 is 1, times another 1 is 1, times another 1 is 1, and so on. So our answer to this is 1. All right, now I've put this one in expanded form already, 5 times 5. I want you to put it in expanded form. Oh, sorry, it's already in expanded form. I want you to put it in exponent form, exponential form, and then I also want you to put it in standard form. So for this one, we've got 5 times 5. So our base number is 5. So that is going to be 5, and then how many do we have? 2. 5 to the 2nd power. Now I just need the answer to this problem. 5 times 5 is, of course, 25. All right, I want to see if I can kind of throw you off here. My expanded form is 2 times 2 times 2 times 3 times 3. Okay, I've got 2 different base numbers here. I've got 2 and I've got a 3. Okay, see if you can figure out what expanded form would be. No, expanded form's right here. See if you can figure out what, I better just write exponent form, exponential form, and figure out what the answer would be. Your exponent form here, we have to do 2 separate exponents. Okay, let's just start with the first part. That would be 2, and there's 3 of them, so that would be 2 to the 3rd power. Okay, our base is 2, and we've got 3 of them. Now, our other part is 3 times 3. Our base is 3, and we have 2 of them. That is 3 to the 2nd power. And then we just have to multiply them together. Now our answer to this, 2 times 2 is 4, times 2 is 8, so this part would be 8. 3 times 3 is 9. Altogether we would have 8 times 9 is 72. Before we start with a couple of practice problems to finish up, I want to give you some special circumstances. Okay? These would be great ones to take some notes on or copy down or put in your own words. This top part is I have a whole bunch of examples of base numbers to the 0 power. 10 to the 0 power, 5 to the 0 power, 16 to the 0 power. Anytime you take something to the 0 power, the answer is always going to be 1. That's one of those ones where I have a tough time explaining, to be honest with you. Okay? But I will just inform you right now, anything to the 0 power is going to be 1. Now, on the flip side down here, 8 to the 1st power, 17 to the 1st power, 2 to the 1st power. Anything to the 1st power is going to be itself. That's pretty self-explanatory. We've got 8, that's the base, and we only have one of them. So if we only have 1 8, the answer is going to be 8. 17 to the 1st, we only have 1 17. That should be self-explanatory. 2 to the 1st, we only have 1 2, so it's going to end up being 2. The last thing I want you to write down for these notes here is, if you ever see the word squared, squared means to the 2nd power. Okay? So for example, 4 squared is 4 to the 2nd power. If you ever see the word cubed, cubed means to the 3rd power. So if I say 3 cubed, that's 3 to the 3rd power. How I like to remember these is, a square has 2 dimensions, so it's to the 2nd power. A cube is 3-dimensional, so it's to the 3rd power. That's just something that helps me. All right, I want you to try these 3 problems on your own. Use the notes that you've taken so far and the knowledge you've gained so far, and try to come up with the other forms that we don't have. So for example, this one I gave you the expanded form. I need exponential, or written with an exponent, and I need the standard form, which is the answer. Here I gave you the exponent form and the exponential form. I want to see it in expanded form and the answer in standard form. Standard form is the answer. Here I gave it to you as an exponent with words, so why don't you come up with how that would look in numbers and then give me expanded and standard. Take a look at that, try it out, and see what you come up with. Alright, let's see how you did. We'll start with, this is probably, I don't know if this is the easiest one, we'll start with this one. Exponential form, or written with an exponent. Our base is 6. 6 is the base. Okay. Our exponent should be 1, 2, 3, 4. We've got 4 6s. 6 to the 4th power, or 6 to the power of 4. Okay. Now we need an answer. All right. 6 times 6, I know, is 36. Okay. Now I have 36 times 6, which is 216. So I'll cross those out because I just did that. That's 216. Now I have, looks like 216 times 6, because we have to keep timesing it by 6, and that would give us 1296. So our answer should be 1296. Now, if you really struggle with this, and everybody should be able to do this, okay? But it is also pretty simple to just grab a calculator, punch in 6 times 6 times 6 times 6 equals. The only problem with that is sometimes people put in too many 6s or too few 6s. Make sure that you're putting in exactly 4 6s. Okay? Now let's go to this one. Let's expand this out here. 3 to the 4th power. Let's start with that. That's 3 times 3 times 3 times 3 times 1 to the 2nd would be a couple of 1s. 2 to the 5th. I don't even know if I'm going to have room for this. Let's see. 2 times 2 times 2 times 2 times, just barely, times 2. 5 2's in there. Okay. Now we just need to do the problem. All right. I think, remembering back to a past problem that we did on this video, 3 to the 4th power, I think, was 81, because that would be 9, 27, 81. Okay, so I'm just going to cross that whole part out, put 81. Okay. We know that 81 times 1 times 1 is still going to be 81. Okay, so I'll get rid of all that stuff and just put this 81 down here. Okay, now let's do this. 2 times 2 is 4, times another 2 would be 8, times another 2 would be 16. 16 times 2 is 32. So I'm left with this problem. Okay, do it on your board. Do it on your paper. I don't have enough room, so I'm just going to use the calculator right now. 81 times 32 is 2,592. 2,592. Okay. Keeping these numbers straight will really help. Just like order of operations, keeping things nice and neat will really help you out. Last one. 10 cubed. Cubed means to the power of 3, or to the 3rd power. So this would just be 10 to the 3rd power. Expand that out. 10 times 10 times 10. Base is 10. We got 3 of them. Now, standard form. Everybody should be able to do this in their head. 10 times 10 is 100. We know that. 100 times 10. If we have 10 100s, that's definitely going to be 1,000. So your answer there would be 1,000.